And this video I'm going to solve this integral which is on the right, this one, but I already have it solved on the left. You can see this whole process. It's because this integral is pretty interesting or peculiar. You can solve it using U substitution, which is a method solved on the left, and you can use it you can solve it using integration by parts, which is what I'm going to do on the right. I'm going to start by writing my super cool table. Writing here, that's very uncool. There it is. There it is. So now I'm going to identify what's going to be U. Well, I'm going to pick U to be the X on the left. So I'm going to take derivative of X, which is going to be 1. Then I'm going to take derivative again, which is going to be the 0. Well, that's pretty easy. Now I'm going to take V prime, which I'm going to pick, of course, the other term, which is the root, X plus 1 to the 1/2. Now here I'm going to write, it's going to be here X plus 1 to the 1/2. Now I have to antiderive this term twice. I'm going to do it kind of quickly on the right. Yeah, I'm going to actually move the screen a bit just to do these integrals quickly. It's going to be like this: the antiderivative of x plus 1 raised to the 1/2. The x here we have to pick a u, which is going to be x plus 1. We take the derivative of this expression, and we will get that du is equal to dx. I mean, you can just verify it on your own if you want to. So this is going to be u to the 1/2 du, and this is going to be antiderivative would be 2 over 3 u to the 3 over 2. I mean, this would be plus c. Now, on this table, we won't be writing the plus c. We're just going to be writing the term, which is going to be 2/3 times x plus 1 to the 3 over 2, which is the one I'm going to write here. 2 over 3 times x plus 1 raised to the 3 over 2. Now I have to antiderive this term again. I'm just going to move this line a bit. There is, I guess that's the best I can do. Now I'm going to antiderive this whole term, but I'm going to use this 2 over 3. I'm going to put it outside of the integral right away. So it's going to be multiplying the result. I guess you can see it's going to be a very similar process to what we did a moment ago. We're going to pick a u, so it's going to be actually the same u in the previous case, so it's going to be looking like this. In this case would be raised to the 3 over 2 du. So we take this antiderivative, it would be like this, 2 over 5 times u to the 5 over 2, this is a 5, we here plus c. And so it would be like this. It would be 4 over 15 times u to the 5 over 2. I'm going to simply substitute in one step like this. 5 over 2 plus c. Now we're going to write this down on a table without the c. So it will look like this. 4 over 15 times x plus 1 raised to the 5 over 2. Okay, that's good enough for a super cool tabular method. Now I'm going to get backwards to okay, let's see. Now we have to multiply this term times this one and this term times this one. The first result must be positive, the second one must be negative. So this integral, I'm just going to write this arrow to say what we did in a moment. Now this integral will look like this. I'm going to actually write the result. This is going to be the result of this one, and I'm going to write it right here just so you can verify and notice in a moment what's going to happen. So I'm actually going to write it better just here above, just to first writing it, and then I'm going to simplify it. It's going to be 2/3 times x plus 1 raised to the 3 over 2. It will be, it's probably 2, so I guess that's better. It will be minus 4 over 15 times x plus 1 raised to the 5 over 2 plus c. Now simplifying this one out, we'll be looking like this: 2 times x plus 1 raised to the 3 over 2 minus 4 over 15 times x plus 1 raised to the 5, this is a 5 over 2 plus c. And now I want you to look at something. The result from the left using u substitution, this one, it's actually different. The result is different than the one we got using integration by parts. Now, why is this happening? I mean, the thing is, even they look different, they actually aren't. So, and I'm going to prove it here in doing this. So, in a sense, what I'm going to do, it's relying upon this. If this may look different, I mean, this may look different, but in a sense, what we're doing, if we equalize a equal to a, now if we subtract a minus a, this should be equal to 0. Now that's what I'm going to do here. Now I'm just going to scroll down this screen a bit just to make more room. There it is. Now I'm going to pick this both guys. So I'm actually going to copy it because it's going to be kind of a long way to write this down. So there it is, the second one. I'm going to write it down here. It's going to be, these two guys are going to be equal. Now I'm going to copy the other one. There it is. And now, just for starters, we can see we have a c, a positive c on the left, and a positive c on the right. So we can just simplify the c like this. And now, what I'm going to do is I'm going to copy. I mean, to move this second term to the left. So it's going to look like this. I'm going to just use here a bit of copying and pasting. There it is. Now, what I'm going to do in the next step is we got to get a common factor out of this expression. So the biggest number that we divide these all the denominators is to say this 5, this 3, and this 15 is actually 15. So I'm going to start first to get the common denominator. So it's going to look like this. It's going to be 2 over 5 times 3 over 3. It's going to be I'm actually going to do it, well, I'm going to just keep this style. So it's going to be 5 over 5. Maybe this is too long. Maybe, feel free to jump forward on the video if you need to. This will be times 5 over 5 times x, x plus 1 to the 3 over 2. This will be here, it's already over 15, so it's going to look like this. It's equal to 0. Okay, now these two guys would get 6 over 15. So it's going to be 6 over 15 times x plus 1 to the 5 over 2. So here's going to be 10 over 15 times x plus 1 to the 3 over 2 minus 10 over 15 times x plus 1 raised to the 3 over 2. It will be plus 4 over 15 times x plus 1 to the 5 over 2 is equal to 0. Now I'm going to get a common factor which is on the denominator is clearly 15. So let's see, I'm going to write it this way. It's going to be here, I'm going to write it, we need more space. It's going to be here 15, it's going to be over now, which is the biggest number that divides 6, 10, and 4, which is actually a2. So I'm going to write here a2. Well, regarding the terms, so we have this x plus 1 raised to the 5 over 2. Here, this x plus 1 x plus 1 raised to the 3 over 2. We have to, in a sense, pick the smallest one. It would be pretty much just like if you have a to the third minus a squared. The common factor is actually the one with the lesser exponents. It's going to be a squared times a minus 1. Well, we're going to apply, in a sense, the same principle. I'm just going to clean this out. So the one with the lesser exponent with this x plus 1 is going to be this 3 over 2. 3 over 2. Now let's do this this operation. I'm going to divide. I'm going to divide. I have to divide this term. Oh, I'm sorry. There it is. I'm going to divide this term over the common factor. Now this is going to be a long process, so I'm going to do it here on the right. It's going to be 6x plus 1 raised to the 5 over 2 is all over 15. Now this is all over 2 times x plus 1 raised to the 3 over 2 is all over 15. Now this is going to be equal. If we simplify this out, we can cancel out these two. This is half 1, half 3. And regarding the exponents, this is 3 over 2. You have to subtract those, so it's going to be 5 over 2 minus 3 over 2, and this will get cancelled, and this one as well. I'm just going to write this way. So you will end up having 2 over 2, which is equal to 1. Now, this is going to look, we have remaining these 3, so it's going to be 3 times x plus 1 raised to the 2 over 2, which is equal to 1. Just not going to write it. And then this 3 times x plus 1 is going to be the one located in here. It will be 3 times x plus 1. Now I'm going to do the same with the second term, which is going to be this one. I'm going to use the green color. So I'm going to divide, would be minus 10 times x plus 1 raised to the 3 over 2 is all divided by 15. I'm going to divide it by the common factor, which is the one in here. So it's going to be 2 times x plus 1 raised to the 3 over 2. It's going to be over 15. Now we can simplify this 15 and 15 like this. Will be half 1, will be half 5. Now this negative sign will pass through to the answer. Now we have here x plus 1 raised to the 3 over 2, and we have the same term here on the other nominator, so we can cancel these two guys out. So this will look like this, is going to be equal to minus 5, and this minus 5 is going to be in here. Now I'm going to do the same with the third term, which is going to be this one. I'm going to use this orange, or I believe it's orange, yes. I'm going to do it down here. It's going to be minus 10 times x plus 1 raised to 3 over 2. This is all over 15. I believe you can notice it's going to be a very similar result as the previous one. Oh, sorry, we have this x, which is multiplying the denominator. To clean this out a bit. We have, I was about to forget this x. So it's going to be 10 times x. There it is. Now the common factor is again this one. So I'm going to divide it over it. 2 times x plus 1 raised to 3 over 2 over 15. I'm going to simplify this out. It's going to cancel these two guys out. This half 1, half 5, and these two will cancel out completely, and we'll end up having again, this negative sign will pass to the answer as well, and we'll have this equal to minus 5 times x. The x was uncancelled through the process, which is this x, and then that's what we're going to write here, and the answer is going to be minus 5 times x. Now the last one, the only one remaining, is to do the same for this term. So I'm going to do it. Actually, I'm going to scroll down a bit to make more room. So it's going to be 4 times x plus 1 raised to the 5 over 2 is all over 15. This is all over the common factor, which is this one. So it's going to be 2 times x plus 1 raised to the 3 over 2 over 15. Okay, now let's cancel out everything that we can. These two guys will cancel out. This will cancel out with this one half. I mean, we have 1, half 2, and I mean this will cancel out 2 out of this. So it's going to be t over 2, and we'll get that at the end. It's going to look like this, which we're going to use the same color. It's going to be 2 times x plus 1 raised to the 1 power, and I'm not going to write this one. So we get here 2 times x plus 1, and we are done with this factoring out. So now I'm going to do something. I'm going to simplify. I'm going to actually simplify what's inside this big bracket. So I'm going to do it here. I'm just going to write quickly this common factor. Will be here x plus 1 raised to the 3 over 2. So this will clear out like this. Will be 3 times x plus 3 will be minus 5. It will be minus 5 times x. Now this 2 will multiply the two terms within in the parentheses. Like this. Now remember, this has to be equal to 0. And now let's see. We have here this positive 3 times x, this positive 2 times x, and this negative 5 times x. So actually we can cancel out these three guys like this. We have this positive 3 and this positive 2 and this negative 5. So we can actually cancel out these three guys as well. So at the end, this whole term will look like this. It's going to be 2 over 15 times x plus 1 raised to the 3 over 2 times 0. And of course, we are multiplying them both, and this is 0, this multiplying the expression. This whole term will cancel out, and at the end you will have that 0, it's identical to 0. So in a sense, what we began to prove that this using this principle, that these two different answers that we found for this particular case, which was originally this one, we found using the tabular method, we found, integration by parts, we found to be the answer this part. And using U substitution, we found to be this answer, which they may look different, but using this principle that we have in the center, we are going to actually use a different color to frame this out. This red looks nice enough. Using this principle, we just proved that these two answers, even though that they look different, they're actually equivalent.